Hello class, welcome to lecture 19, and in this lecture we're going to talk a little bit about fronts and take a look at some of the mathematics behind fronts. So that's what we have to look forward to. Of course, a good first place to start might be to take a look at the definition of a front, but as it turns out, there's actually no universally agreed upon definition of a front. But there's a couple of definitions that are pretty widely accepted, and we're going to talk a little bit about them. So the first of which is a front can be defined as a boundary that separates two air masses with distinct physical characteristics, or with different physical characteristics. And a lot of times in the atmosphere, this is a boundary that separates cold air from warm air, or usually the way it turns out, it's more of a boundary separating cold, drier air from warm, moist air. And that's usually what we see in the vicinity of a cyclone. So again, that kind of feeds back to the topic that we talked about in the previous lecture, which was the anatomy of a cyclone, where you have typically a cold front and a warm front being involved. And a lot of times fronts are associated with temperature gradients. So again, cold, dry air being separated from warm, moist air, that is of course going to give you a temperature gradient, but not all temperature gradients are considered fronts, and this is where the definition of front gets in kind of a shaky territory. Because technically right now there is a temperature gradient probably where you're at. So you're probably in a nice cool building on this hot summer day where the temperature inside the building might be, say, 75 degrees Fahrenheit, maybe a little bit cooler or a bit warmer. And then outside it is probably brutally hot. If you're watching this in the afternoon, it's probably 90 to 100 degrees. There is a temperature gradient between your building, the building that you're in, and the outside atmosphere. But that temperature gradient is not big enough to be classified as a front. And there's a lot of questions about what temperature gradient is, what is the big enough temperature gradient to be classified as a front? And the most widely accepted definition is a temperature gradient that is at least 100 kilometers in a typical length scale, and also a front that extends at least 1,000 kilometers in a synoptic scale. So fronts are kind of a mix between a synoptic scale and a mesoscale phenomenon. So again, not every temperature gradient can be classified as a front. Typically, we want to look at a temperature gradient that is at least 100 kilometers, is a space at least 100 kilometers, and then also extends about 1,000 kilometers in the direction of the front itself. So again, no formally and widely accepted definition of a front, but the definitions that are most widely accepted are typically good enough for our intensive purposes. So again, front is typically classified as a temperature gradient that has a synoptic length scale and separates two clearly different air masses. So this kind of combines the best of both worlds here. This combines the idea of temperature gradient being involved, and also the idea of a boundary separating two distinct air masses with different physical characteristics. And some other properties of fronts that we can talk about. One is that fronts are often associated with a wind shift, and this is something that I imagine you've experienced at least once in your life if you lived anywhere in the mid-latitudes. When a cold front comes through, the wind just starts howling out of the north, especially if you live in the plains. The wind just starts howling out of the north at 20 to 30 miles per hour, and it was calm and out of the south, relatively calm and out of the south just a few minutes prior. And yeah, the cold fronts, especially if you live in the plain states, when those cold fronts come through, they really make their presence known when that wind turns around to the north and starts blowing really hard. Also, as what you commonly see with fronts is a difference in weather patterns, and by this we mean fronts often separate regions of unsettled weather from regions where the regions of the atmosphere where the atmosphere is stable. You don't have any shower or thunderstorm activity, or you don't have a lot of clouds for that matter. But on the unstable side of the front, that's typically where you have an unsettled weather pattern where there might be lots of precipitation, showers and thunderstorms, even maybe some severe weather if the atmospheric conditions are favorable. But also fronts typically separate an unsettled weather pattern from a stable one. Another interesting thing about fronts is right in the near vicinity of that strong thermal gradient, you have a region of locally lower pressure. And when we talk about identifying fronts, you'll see what exactly I mean and how that will show up on a weather map. But fronts right at the interface between the two air masses of distinct different characteristics is in a region of locally lower pressure, and that's partly due to the fact that you've got some sort of vertical motions taking place. You've got some sort of reduced pressure in the atmosphere occurring right at the interface of the front between the two boundaries that it's separating. And another interesting thing about fronts is typically when we look at fronts, we're looking at a surface map, but you can also have fronts that form aloft. So you can have thermal gradients that occur even as high as 500 or 300 millibars in the atmosphere. And we'll briefly touch on what can happen with those, but primarily what we're going to focus on is what happens down at the surface. So that's going to do it for this first segment, just introducing the whole concept of a front as well as some of the characteristics. And in the next several segments, we are going to cover several different types of fronts that you can see in the atmosphere. So with that, I will see you all in the next segment.